For those who are listening, I'll just give a brief intro about myself and where I come from and how I'm working on stable channels. I've been working on Bitcoin full-time for about a year, and before that I was employed at JP Morgan Chase, and I worked on their stablecoin projects there. And let me tell you, I'm more than thankful and more than thrilled to have left that and now be working on full-time on decentralized tech, Bitcoin, and my project called Stable Channels. So thank you folks for joining me after your break. I hope that you are caffeinated and interested to learn some more about what we got going on here. The first couple presentations today talked about pools and pool concepts. This will talk about the Lightning Network and channels and more of a peer-to-peer approach rather than pooling technology. And so again, my name is Tony and I'm working on an open source project called Stable Channels. And Stable Channels is meant to be an alternative to stable coins built on Bitcoin. Stable Channels is peer-to-peer stable dollar balances on the Lightning Network. And so who of us can deny the fantastic and tremendous success of stable coins? Really just in the past 5 years, their volume has exploded. I think we understand why stable coins are popular around the globe. A lot of people don't have access to US dollar bank accounts, and in the crypto ecosystem, it's been difficult historically to get access to US dollars and to get access to US dollar bank accounts. But of course, stable coins like USDT and USDC are not Bitcoin, they're more like bank coin. When your money's at USDT, your money's essentially at a bank. And Tether can turn off your money anytime Tether wants to. It's certainly not decentralized. And it faces some of the old-fashioned regular problems that Bitcoin is trying to fix, like bank runs, or your money can get frozen or seized, or your money could get caught up in some type of bankruptcy proceedings. We know this from centuries of monetary history, don't we? And as Bitcoiners, can we offer a better solution than Tether and stable coins? And can we offer a solution that can help users with Bitcoin's crazy volatility while staying true to the ethos of Bitcoin, which is decentralization and permissionlessness? I think we can, and I'm going to present on that today on my topic, stable channels. First, I'll mention that when it comes to stable dollar balances, there's different ways to do it. Of course, there's regular bank accounts and there's stable coins. There's also a couple of other approaches in the Ethereum ecosystem. There's something called DAI. There's another product called Athena, which has really taken off this year. And the way that works is essentially it matches up longs and shorts, and you can pool your money into this Athena US dollar coin. And it's a centralized approach, but they issue a token on the back end. In the Bitcoin ecosystems, there's a couple of approaches to offer a dollar-based product. One of those products that you may be familiar with is StableSats. That's offered by Galoy. And the way StableSats works is you send $100 to Galoy, and then Galoy on the back end takes a short position with an exchange to protect against the price of Bitcoin going down and the user being left with less than $100. There's also an approach using DLCs or discrete log contracts. I won't necessarily get into all of that today, but needless to say, the DLC approach has not gotten product market fit quite yet. So what do I propose? Yeah, so what I'm saying is that tokenizing dollars, not cool. Obsoleting dollars, cool. Bitcoiners, I think we can do better, can't we? So what I propose is stable channels. And what this does is it matches up two Bitcoin holders on a Lightning channel, a regular Lightning channel with no real modifications to it, frankly, to stabilize Bitcoin at a particular US dollar price. And so we have the channel, which is a regular Lightning channel, and on one side of the channel we have who I call the stable receiver. That's the actor or the counterparty who wants to be kept stable at a certain dollar amount, for example, $100,000. So this user, this is a person who has Bitcoin. Bitcoin gets to $100,000. They say, okay, I like that price. I want to lock it in. And so this user puts 1 Bitcoin into a channel, and we match this user up with another user who is the stable provider. This user wants extra volatility. They want 2x levered Bitcoin exposure. And so they say to this other user, hey, you don't want any more Bitcoin exposure? I'll take your Bitcoin exposure, and I promise to keep you stable at $100,000. And so each of these users is running a Lightning node, and each of these users is running the stable channels software. And what we do is every, say, 1 minute, each of these actors queries the latest US dollar price for Bitcoin from several different exchange price feeds. For example, Kraken, Bitstamp. We query 5 different price feeds, and we take the median price of those price feeds. And then one of 3 things has happened in the past minute. Either the price of Bitcoin has stayed the same. It stayed at $100,000. In which case, this user still has 1 Bitcoin and $100,000 and they're still stable. Another scenario is that the price of Bitcoin has gone down. In that case, that means the stable provider needs to send a payment to the stable receiver to keep this user stable at $100,000 because it's going to take more than 1 Bitcoin to keep the user stable at $100,000, right? The third scenario is that the price of Bitcoin goes up. In that case, it takes less than 1 Bitcoin to keep this user stable at $100,000, and this user sends a payment over to the stable provider. So I think this is just what everybody wants to do after a long day, which is to think about the math here. And we have some of these payout scenarios, so let's take these scenarios. So in this case, where there's no change, each user put in 1 Bitcoin into the channel. That's 2 Bitcoin of total capacity. That's $200,000. And at the start, each of these users has $100,000. Now let's take 2 other scenarios. Let's take the scenario where the price goes up a lot. The price goes up to $200,000, right? That means that there's 2 Bitcoin in the channel still, but there's $400,000 in the channel. But remember, we were just keeping him stable at $100,000. So he only needs 1/2 of 1 Bitcoin to keep this user stable. But this guy did great. This guy was levered long. And this guy made an extra $100,000. This guy earned 0.5 Bitcoin from this trade, as you will. But of course, there's a flip side here, right? What happens if the price goes down a lot? If the price goes down a lot, well, we have a challenge. If the price goes down to $50,000, there's still 2 Bitcoin in the channel. But those 2 Bitcoin only add up to $100,000 total in the channel. In this case, both of these Bitcoin are on the stable receiver side of the channel. We've kept that user stable at $100,000, but we can't tolerate a further drop in the Bitcoin price and expect to keep this user stable at $100,000. It won't work anymore. In that case, we can think of this user has gotten liquidated. There's not enough Bitcoin in the channel to keep that user stable, in which case we have several options. We can recharacterize the channel as a regular Lightning channel. We can close the channel. The user can say, remember, we're connected to the Lightning network. The user can say, I want to go and swap over Lightning, and I want to go to Coinbase, or I want to swap to Tether. There's lots of different things we can do. Or we can splice more capacity, put more Bitcoin into the channel, so that this guy has more Bitcoin to continue the arrangement to keep this guy stable. So let me tell you a little bit about some of the operational challenges and operational opportunities that we have with stable channels. The challenges that we have are similar as those with Bitcoin and Lightning. You need to run a Lightning node. There are some complex software and edge cases with Lightning that many of you know about. You have to manage these hot private keys. This is a self-custodial system in the base case. As you know, you can run into a potential high fee environment which affects the dynamics of Lightning channels. And you need to start with an on-chain transaction to create the Lightning channel. These users have to be online, both to make the payments and to query the price feeds. And there's no necessarily guarantee of performance. Each of these users can leave when they want to. Some people call this a free option problem. But my thesis is that with Lightning, we've unlocked a new capability, which is the ability to send these extremely fast and extremely cheap payments. So what happens when we can minimize the time value of risk of your counterparty to mere seconds? But remember, under the hood, even if your counterparty says, no, I don't want to play this game anymore, under the hood, it's still 100% Bitcoin. You always have custody of your Bitcoin. And I think that despite all of these challenges, when we have this essential fact, we can work out all the rest of it. Yeah. Woo! I'll say that if anybody has any questions during the presentation, feel free to raise your hand and I won't be interrupted. Please, sir.
2 questions. First, do I have to open a new Lightning node to run the software? And the second question, can I use the Lightning node normally to make transactions while I'm running the software?
Yeah, those are both great questions. And as far as the characteristic of the Lightning node, I'll get to it, your first question. And on the second question, yes, but with caveats. And the caveats are this. If you're receiving, for example, via the stability provider to your receiving payments to your side of the Lightning channel, then what that means is it's depleting the collateral from your counterparty and it's going to your side of the channel. So that can be a challenge, right? Because if the channel is, if we're keeping you stable at $100,000 and then you want to receive a $90,000 payment, right? You know, then that has depleted $90,000 of over-collateralization on one side of the channel, right? That's for receiving. For paying out, there's really no problem because effectively what you're doing is you're paying through your counterparty, and so your counterparty is keeping you stable at a lower value. So there's more money on one side of the channel and less dollar value to keep you stable. But we'll get to that as well. So when I think about the opportunities with stable channels and related technology, I think about it as streaming finance. And what can we do with streaming finance? Well, we can offer the stability as a service, of course, and say, yes, I'll keep you stable. I'll take your extra volatility, of course. We can also do derivatives trading and perpetual swaps. For example, some users may want to be stable in euros. Some users may want to be stable at S&P 500. Who knows? We can do USD payments where we can abstract away the Lightning and the Bitcoin so users can just see a US dollar interface. We can add in regular interest payments that go from either side depending on the market dynamics. In the land of perpetual swaps, this is often called a funding rate. It means a percentage that either longs pay shorts or shorts pay longs. In BTC USD funding markets, around 80% of the time, longs pay shorts. So in our example, the stability provider would be paying a regular interest payment to the stability receiver, often double-digit interest rates annualized. And we can do these interest rate payments as often as we want. And we can do this all with no fiat, no tokens, and no banks involved. This is a permissionless technology. It can be private, very peer-to-peer and permissionless. It's self-custodial, and I think we can use a mechanism like this to turbocharge Lightning and a turbocharge Lightning liquidity by offering new business models to Lightning node runners. So getting to your question about the Lightning node, I want to talk a little bit about the technical journey I've made in Lightning land to make this work. I've tested a full spectrum of tools. I started out with Polar, testing this with Polar, and it's a point-and-click desktop application that you can get to know Lightning. I recommend it. And then I moved to LND and CLN with some Python scripting. And with that, I was able to make an operational product, which I'll show to you in just a moment. And it works great, frankly. But it's not a holistic solution for users. So it's not a holistic application. I experimented with Core Lightning plugin, also worked great. And I tried Core Lightning Greenlight, which is a product to make it easier to run Lightning nodes. What I settled on was LDK, which is called Lightning Dev Kit, which is an open source project sponsored by Spiral, and Spiral is sponsored by Block, and Block is a financial services company founded by Jack Dorsey. And I like it because it's all Rust. Everything is one programming language. It's one program that I can get it up running, and it has the user interface, and I'll show it to you how it works. And optimistically, this could be cross-platform, and everything is kind of self-contained. I just like how it's working for me. The primary functions of the code that I've developed so far are the price feeds and logic that connect to the exchange APIs and handling that. The basic payments logic, I expect to be paid this much, or I need to pay the other guy this much. And the risk handling if something goes wrong. And then finally, the user interface and the UX is another part of the code. So I want to talk about two use cases, and then I'll show you how it goes. So the first use case is what I was able to use, get going, just with those LND Python scripts and those Core Lightning Python scripts. And this is the same setup that I just showed you earlier. But what we do in this case is we add on an eCashment to the stability receiver side of the channel. And then users access this stable channel, this eCashment, via a web UI, which is called Boardwalk Cash. Some of you may have seen it. I'll show it to you in just a moment. And then a user, a custodial user, frankly, but a self-custodial of these IOUs, is able to access this Boardwalk Cash web UI. This web UI hooks up to this eCashment. This eCashment is running the stable channel. I'm providing the stability for this developer who runs this eCashment. So let me just show you that. And so this is the website Boardwalk Cash. And Boardwalk Cash, you can have eCash tokens in Bitcoin or dollars. These dollars are not Tether dollars or bank account dollars. These are stable channel dollars. Yeah, thank you. And so this user can connect to a different eCashment. And so this user has connected to this StableNet UMint Cash website. And with this guy, we have a $5,000 stable channel. It's been operational for almost a year now. And we've done about, we settle every 5 minutes. And so we created the stable channel. You can go on the Block Explorer. You can check it out. And we started having the same number of sats, but when we started this, the price was 62,000 or so. And I've done quite well on this because the price has gone up, obviously, to 90 some odd $1,000 since then. So this illustrates the case where the stability provider can enjoy more sats if the price goes up. and the stability receiver loses sats if the price goes up. We can see charts where we've kept the user stable, and then as I mentioned, we settle every 5 minutes, and so the operator of this eCash mint posts to Nostr every time we do a settlement event, and he gives the current balances, and we keep track of things that way. So that's the first use case I wanted to mention.
How come it's not exactly 5,000? How come it's a plus a little bit?
I think that's related to something with the calculation with the reserve fees or something like that, or maybe anchor outputs. Something like that is giving that somewhat above 5,000.
So it doesn't settle to 5,000. It settles to slightly above 5,000.
Yeah, with that little bug in there, yes. So use case number 2 that I want to talk to you about is like an LSP-enabled app, which is more truly self-custodial. And in this case, we can think of the stability provider, the stable provider, as an LSP. This is kind of like the Phoenix model, if any of you have used Phoenix. And so in this case, Phoenix is handling the relationship to the rest of the Lightning Network, and then this user has a channel open with the LSP or stable provider. We can think of this again as kind of like Phoenix, and then this user is receiving the stability, and both of these actors still are running Lightning nodes, still are running the stable channel software, and this is what I'm working on with the LDK solution and the app as I'm working on it now. So I'm going to demo you this desktop app that I'm working on, and then this user, this self-custody user accesses the desktop app, and the desktop app connects to the LSP or the stable provider. We've taken that base stable channels code and we've added in some LSP functionality. For example, I've added in the capabilities to have just-in-time channels or on-the-fly channels, and I'll show you that onboarding, how that works. And then again, just like how Phoenix connects to the rest of the Lightning Network, in this model, the user has this private stable channel, stable channel with the LSP, and then the payments are routed, via Phoenix or via this LSP or via the stable provider to the rest of the network, or the other way. So let me just show you this demo video of how this onboarding approach might work. And so in this case, this is the desktop app icon for stable channels, and over here I've got a little web app that mocks this might be Coinbase or does Kraken have Lightning? I don't know. So, oh, is that right? I thought Coinbase was adding it. Regardless, any Lightning-enabled exchange, let's say River, a Bitcoin first one. And so what happens is the user will open up the app. This kicks off the initialization of an LDK node. It happened quite quickly. Whoops. I want to show you what's going on here. And the onboarding steps for the user should be pretty simple. They'll get an invoice, a Lightning invoice, and then they'll press the stabilize button. They'll see a QR code, which shows an invoice for a just-in-time channel. They'll pay that from here. And then what's going to happen is the LSP will intercept that payment and create a stable channel on the fly. It's called a just-in-time channel, and then the stable channel will be created. So the user will press that button, the user will get the invoice, the user will go to Coinbase or whatever, River, and pay the invoice. And what happened there was that payment was intercepted by the stability provider or the LSP, and the LSP goes ahead and receives that $20 payment and also puts in their side of the channel $20 as well. It's essentially a dual funded channel. And then the regular stability mechanism is kicked off. And with this desktop app, I think we settle every 30 seconds. So that's the second use case I wanted to show you. Thank you. We're working on it, folks.
Tony, I have a question.
Let's do a demo. Let's do it live.
Tony, I have another question.
Yeah, buddy.
In your LSP model, when I talk to other LSP developers, they talk about two models of how the LSP gets paid for creating an on-the-fly channel, and they talk about a client trusts the server model and a server trusts the client model. Do you know what those are, and can you share which one you picked, or if you figured out another solution?
Yeah, you're right. So this is the user trusts the client trusts the server model. And now the characteristics of that trust are a little bit tricky. But I think when they generated that invoice, the trust is actually that the trust is that the LSP actually broadcasts the channel creation transaction. But the LSP cannot take that money because the pre-image was generated on the client's device. So you're trusting that the service provider, who let's assume is a business or wants to treat their customers right, will actually broadcast that channel creation transaction, but I don't think that they can actually take the money because they don't have the pre-image what was supplied by the user. The other approach, I don't know. I don't know how that one works.
So what happens if the user never gives them the pre-image?
Then they can't make a Lightning payment because the Lightning payment, when they generate that just-in-time channel invoice, there's cooperation with the server because the LSP, because the LSP says, hey, this is my Lightning node, route through me, right? And then that's the way that they can intercept the payment and then create the stable channel.
But it sounds like there's a cost to creating this channel, but they only get reimbursed for that cost if the user gives them the pre-image. So the user can grief them by not giving them the pre-image and making them lose money.
I don't see that.
I'll talk to you afterwards.
Yeah, no. That stuff's tricky. This is all in specs called LSPS1 and LSP2, LSP service spec, LSP specs 1 and LSP specs 2. What I'm using is LSP2 just-in-time channels, and those are specifications that are frankly quite involved. So we'd have to dig into the nitty-gritty. So yeah, let's do this live. So what I'm going to demo here is just the basic mechanism of the stability receiver and the stability provider, and then the basic payments that they do with each other. And so I'll show you the GitHub repo here. Well, I'll show you the GitHub repo. Here it is. And I've cloned this repo onto my computer here. And we're going to go ahead and run this app twice. We're going to run it once as a user and once as the LSP. So let's start it up as the user. What I'm going to do here is I'm going to get an address, and we're going to fund this on the Mutinynet faucet. And so we'll go to Mutinynet. This is just a test network, and we'll give this user 1 million sats. And what we're going to do is, okay, good. And then I think they have like 30-second blocks, so this should show up in like 30 seconds. And right now that balance says 0. But we're going to use the money that the user got to fund both sides of the stable channels just for this testing environment. We'll go ahead and run the app as well. Cargo run -- features as an LSP. It's the same app as, we will go into the stable channels directory. And then this just runs it from the LSP side of things. So what I see on my screen is that the user has gotten their Bitcoin, And so what I'm going to do now is I'm going to run a command that is going to go ahead and open up a channel to the LSP. And this is going to look like open. The command will be open channel. And I'm going to get the pub key from the LSP. I'll copy that in there as we open this channel. And you know what? I can just tell you all anything I want, can't I? Because you guys aren't going to know. I can tell you this demo is going to work. Yeah. And then I'm going to open this channel for $200, and then we're going to just go ahead and send $100 to the other side of the. So 132 sats. That's $200. And the channel, it says the channel opened successfully to the other user. Yeah, this isn't going to work. I'm not going to. But basically, what I do in this little demo is I open the channel between the two users, the two windows that I opened up where I had the user window over here and the LSP window over here. And then once the channel was up, I run a command called start stable channel, and then I put in the respective values for each of these user types. And then you see that it queries from the exchange price feeds, it takes the median, and then it does the appropriate payments to keep the one side stable. So that's all I was going to show. And you can try it out as well. You can go to the Stable Channel's GitHub, and it should work. If it doesn't work, let me know. We can sit together, and I'll take questions from everybody. Thank you. Thank you. This gentleman had a question. He raised his hand first, right there. Yep.
Yeah, I want to ask about failure modes. You said both parties take feed from different exchanges, a price feed from different exchanges, right?
Correct.
And then take the median. And what happens if, for instance, one of them, for some reason, skips or doesn't get one of these exchanges price feed, and then they cannot agree on the price? How resilient is it to that? Will they immediately settle at that moment, or is there some leeway? Some.
Yeah. So this is peer-to-peer technology, and so it depends on what your relationship is with your counterparty. Like for example, with that one that I showed with me and the eCash Mint, I know the developer of that eCash Mint, and on occasion we've had not too many issues. We've done about something like 100,000 payments back and forth over the past year or so. But on occasion, I think CLN had a bug one time and it stopped. And so, he messaged me and says the stability mechanism is not working. I go in, I restart the CLN, and it works. With respect to the price feed specifically, yeah, it can be the case that they're slightly off. And even if you're trying to do your best, they can query the prices at a slightly different time and get a different result with taking the median as it is. This isn't meant to be a perfect solution. And my theory on this is that if you're trying to keep a pot of Bitcoin stable according to the value of some external asset, you're going to have a challenge because Bitcoin only settles every 10 minutes, right, at the end of the day. And the price of Bitcoin changes every 10 seconds. So with respect to, but overall, it's going to depend on the threat model and how much you trust the counterparty and how much money's at stake. If it's like a $100 stable channel and it's only a few bucks, who cares? If it's a $100,000 stable channel and it's thousands of dollars at play, we're going to have a different model to handle all of that. And so it's going to depend on the specific implementation. I hope that helps.
So I have a few questions. One being that specifically, I noticed that we're trusting a centralized party for the price feed. So, and you did bring up at the beginning of the conversation DLCs. So is this integration, is it compatible with DLCs so that we could have a secure, Oracle? Or, yeah.
Well, that's a great question. Let me kind of compare and contrast with DLCs. I actually think that the threat model with DLCs is more serious because when you put your money in a DLC, a DLC is a 2 of 2 multi-sig that uses adapter signatures. It's effectively a 2 of 3 multi-sig. So in a DLC approach, it would be like these 2 trade counterparties, and then the third key would be a price feed, basically, right? And the kind of challenge there is that you're giving
Actually, I'm not comparing specifically DLCs, the implementation of doing what you're doing with DLCs. I'm talking about the price feed.
Yeah.
Because your price feed could get hacked.
I got you. I'm getting there. And so with the DLC approach, like you're actually giving custody to the oracle, the price feed, right? And so it is a different model. With my approach, we use 5 different price feeds, right? And we take the median of those 5. And so that means that really 1, 2, 3 of them, well, 2 of them could give values that are crazy, and we'd still be okay because we take the median, right? And so it does have a reliance on price feeds, and this is why we use several of them. But I think it's reasonable to do that.
But you guys don't have compatibility where we could use a DLC for the price feed?
So, a DLC related price feed is like, it's a signature that like you're able to decrypt a counterparty signature to make a 2 of 2 multi-sig valid. And so there may be some type of combinations of stable channels and DLCs that might, and I've talked to this with people who work on DLCs, where there might be some type of hybrid approach, which might make it worthwhile. But DLCs are they're not a silver bullet. They have their own challenges as well. And but I think to answer your question, it could be a case that some type of hybrid approach with in the happy case, we do the regular stable channels settlement, and then somehow there's some type of DLC fallback. That could be the case too. But they're a little different.
Okay. And my other question is, Super Testnet earlier, he was talking about pools.
Yes.
And I was curious, could this be implemented more in a pool type manner?
I don't know. I don't know enough about, even though I was present for his talk, I still don't quite understand it completely. But I will say that I think specifically with ARC, I think that virtual stable channels and virtual UTXOs, I think there might be something really exciting with the combination of those things. With the payment pool things, Super just left, but we'd have to brainstorm with him.
Okay. And on side chains, we're utilizing the Lightning Network on Bitcoin, but let's say that we wanted cheaper transaction fees, or I guess cheaper means of moving the funds. Could we use something like Liquid Network to implement this?
Yeah, you could. You could have a Lightning on Liquid stable channels. Absolutely.
Cool.
Any other questions from folks? Sir, there's one question up there.
Have you thought about adding multiple parties to make the system more decentralized? For example, with some stability pool where participants can join and leave freely.
Yeah, I've thought about it, and this is kind of related to what Oflo.
It's basically continuing the previous question.
Well, so for example, I think it could be interesting if you have an operator who has channels with many different types of customers, and then routes payments from customer to customer, like via that counterparty, so that you can have easier leaving the trade, entering the trade. So yeah, I think that could be a design possibility. Fundamentally, this uses Lightning channels, and Lightning channels is really a peer-to-peer technology, and so that's kind of how it works fundamentally. But I do think you don't necessarily have to have a one stable channel. You might just say like, hey, user over there on that side of the Lightning network, I want to be stable at this amount. and user over here wants to provide that stability, and they might want to route through intermediate users, right? That's a possibility, but you might, lose some money to fees, for example, and it's not, necessarily as clean technologically, right? Because you're involving all of these other actors whose liquidity might get drained. Like, I don't know, but I think the design space is really big here.
Yeah, and that's interesting. Another question: are there any price matching algorithm consensus based? For example, if two parties are not agreeing on the Bitcoin price.
I don't know. So in my version that I showed you today, each side of the stable channel has their own. You think it's going to work? It's all right. Each side of the stable channel has their own version of the truth. It's because they both independently query those price feeds. I think each actor querying, Kraken.com or Coinbase.com, I think that's pretty good. I think that's a pretty good solution, and those price feeds, in my experience, have been tremendous uptime. They almost are never down. But maybe you're talking about something, a little bit more sophisticated, which I don't know about.
For example, if one party has lost connection with some providers, or it tries to cheat by mimicking that it lost connection, and make decision based on two sources, for example, which is more favorite for them?
Well, again, if I get the price and it's clear to me that the price is 97,000, and then the other guy gets the price and he says, well, it's 94,000. We have a disagreement about that, and it's going to depend on the nature of whether I like you or not like you, or if you've behaved well for the past 5 months and now you have this legitimate concern, or, oh, in fact, it just happened to stop working at the exact moment where the price went the way that hurt you. There's all sorts of considerations where we can kind of figure out if this guy's going to try to cheat me or not. But yeah, I hope that helps.
Okay, one more question. What are your thoughts about risk mitigation strategy for stability providers?
I think it's going to depend on the amount at risk. And I think for a really high amount, you'll probably want to know your customer, frankly. And so I think that's a risk mitigation strategy. Another one, which is kind of simple, is we have a contract. We have some type of legal contract. And if you don't pay me what you're supposed to pay me, then I can have some type of legal recourse. So maybe this technology will be beneficial for, traditional finance, for settling derivatives trades, something like that, between actors that are well known. It's going to depend on the amount at stake and whether you have some type of history with this user. If the user has behaved well for, some number of months, then maybe you can say, well, I'm going to bump up your potential capacity from 1,000 to 10,000 because so far you've behaved very well. The price changes a lot and we settle frequently, so you will know soon if your counterparty is misbehaving. But of course, I think just a month or two ago, the price of Bitcoin went in 15 minutes, it went up 10%, something crazy like that. So that can definitely happen.
That's interesting. Maybe there is room for some platforms that will manage user reputation.
Yeah, I think so. I think this is also an example where some type of hybrid approach with DLCs, some type of fallback to DLCs might be interesting.
Thank you so much.
Thank you.
So in the RGB model, we use a lot of client-side validation, and the data is basically stored by the user. How is the data handled in your protocol?
The data that is handled is these are regular Lightning channels, and so each side of the stable channel keeps track of all of the transactions that happen, between himself and the channel partner. And so that's where the data is stored. And then the other aspect with the data is that you query those price feeds, and we keep track of that, as you're querying those price feeds. That's another piece of data. And then I think the final piece of data is data from the Bitcoin blockchain itself, right? And data that's relevant for that for Lightning includes fees, or whether your counterparty has tried to force close on you or whatever. And for that, we will probably use like an Explorer or a blockchain explorer where you connect to get data from the Bitcoin blockchain. So that's a trusted, a trusted-ish solution. But as you may know, Lightning, you can run your own full node with Lightning just fine, and then you have the data there. So that's kind of the contours of the data involved in the system.
So
Okay, we're about 10 minutes over time. We got to move on to the next session, guys. Thank you so much.
Sorry. Hey,
Thank you,
thanks,
Tony.
guys. Obrigado.
Sorry for the technical issues.